Good morning. Today I am going to explain the seventh question, the unit number 4, the IT student. The seventh question, that is, explain the principle, construction and working of diode laser. Sometime instead of diode laser, the question is semiconductor diode laser. The semiconductor diode laser means also the same question answer. So semiconductor diode laser or simply diode laser. So now we go to the deep of this particular question. So what is laser? No, what is laser? Laser actually is a light. The full form of laser is light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. The short form is laser. Comparing ordinary light, laser light is a monochromatic and also coherent light. It is very useful in most field, particularly in medical field, industrial field. The laser lights are very useful. So here we have two different type of semiconductor diode laser is there. The first one is homojunction semiconductor laser. The second one is heterojunction semiconductor laser, diode laser. So we have two different type of diode laser. One is homojunction diode laser, the another one is heterojunction diode laser. Then what is mean by homojunction semiconductor laser diode, that is diode laser. Homojunction means same type of semiconductors are available on both side of the junction. Same type of semiconductor is used on both side of a junction means the type of laser, that is diode laser, is homojunction. If different type of semiconductor used on both side of the junction means that is heterojunction. Homojunction, same type of semiconductors are used on both side of the junction. Here heterojunction, different type of semiconductors are used in the both side of the junction. So that's the difference of homojunction and heterojunction diode laser. Here I am going to teach about the heterojunction diode laser. For that the principle is very simple. The principle is simply the recombination of hole and electron. As a result of that the light will be come out. Here in this case the emitted light in the range of laser. That's all. So ordinary principle, recombination will be taken place between the p-type and n-type semiconductor through that depletion layer. As a result of recombination, a light will be come out. Here the light is high intensity light, monochromatic light, extremely high intensity, and also does not diverge at all. So that type of light we named as laser. And we further move to the heterojunction in detail about the heterojunction diode laser. Then construction of heterojunction diode laser. You see about the construction. This heterojunction diode laser, which have five layers are there. So it consists of 5 layers. Five layers are there. This is one, and second, third, fourth, and fifth. Here it is a metal contact. Actually, 5 layers are there. Then what about these 5 layers? The different layers name. Here one metal connection is there, and here this another one metal connection. This is a battery connected externally. Positive terminal connected to p-type semiconductor, negative terminal connected to n-type semiconductor with the help of the metal contact. Here it is a metal hook, a metal contact that give a suitable power supply to this diode laser. So now this is a construction which consists of 5 layers. So among the 5 layers, already told that heterojunction diode laser which have different type of semiconductor on both the side of the junction. So here, out of 5 layers, the first 3 layers made up of p-type semiconductor. And also in this p-type semiconductor, the first one is gallium arsenide, GaAs. GaAs is p-type semiconductor. Gallium arsenide p-type semiconductor. The second layer is gallium aluminium arsenide, that is also p-type semiconductor. Gallium arsenide p-type semiconductor. Gallium aluminium arsenide p-type semiconductor. Then the third one is once again a gallium arsenide p-type semiconductor. The fourth one is gallium aluminium arsenide n-type semiconductor. Then the last one is gallium arsenide n-type semiconductor. So the last 2 layers are n-type semiconductor. The first 3 layers are p-type. Once again, gallium arsenide p-type, gallium aluminium arsenide p-type, gallium arsenide p-type, then gallium aluminium arsenide n-type, gallium arsenide n-type. So these are the 5 layers. This 5th layer is also act as a substrate. Over that all the layers are grown. Then here it is a metal contact which help providing a suitable power supply, that is forward biasing. This is a forward biasing. P-type semiconductor connected to positive terminal, N-type semiconductor connected to negative terminal, that is forward biasing. Now this is the construction. 5 layers are there. The third layer, named as the third layer, is active layer. The third layer is active layer. This layer made up of gallium arsenide p-type semiconductor. Then between third layer and fourth layer, this junction act as a depletion layer. Then from this the emission of laser, the laser light is come out. A laser light is come out between the third and fourth layer. That the junction between third and fourth layer, the possibilities of emission of laser. The laser and that wavelength is actually 8014 Armstrong unit. 8014 Armstrong unit. Armstrong unit, that is the wavelength of the laser light which come out from this particular junction. So what is it? The A on both side of junction. This is a junction, the main junction where the laser light is going to be come out. And the both side of the junction made up of different semiconductor. This is a junction, over that p-type semiconductor, under that is below that one is n-type semiconductor. So it is heterojunction semiconductor diode laser. The meaning is good. Then this is the construction over. So totally 5 layers are there. 3 layers are p-type semiconductor, the last 2 layers are n-type semiconductor. Among that, the third layer is named as active layer. The second layer and the fourth layer. That is gallium aluminum arsenide p-type, gallium aluminum arsenide n-type. That have high bandwidth semiconductor, low refractive index. Gallium aluminum arsenide p-type, that is second layer. Gallium aluminum arsenide n-type, that is n-type semiconductor, that available second and fourth layer, having high bandwidth and also low refractive index. That is very important. These two are high bandwidth and also low refractive index. For refractive index semiconductor, we select on that regard for that construction of heterojunction, that is diode laser. Then we move to the working procedure of this particular heterojunction diode laser. When a suitable forward bias is provided externally with the help of the metal contact, the lower end, that is this is now named as cathode, this is anode. A p-type semiconductor, positive majority part. Here n-type semiconductor, that is negative charge is majority. So now suitable forward biasing is provided. The charge carrier from second layer and fourth layer. The charge carrier from second layer and fourth layer. Once again, what is second layer? Gallium aluminum arsenide p-type. What is fourth layer? Gallium aluminum arsenide n-type. The charge carrier from second layer and that of fourth layer that crosses and enter into the active region. Which is active region? The layer number 3, gallium arsenide. So charge carrier from fourth layer and the second layers are enter into active region because of the providing particular forward biasing. This negative terminal which repel the electron, the positive terminal which repel the positive charge hole. So that crosses the junction and enter to active region, that is third region. So now active region where the electron from the second, that is electron from fourth layer and hole from second layer entering. Now the recombination process will be taken place. As a result of recombination, there is a emission of energy. The emission of energy is in the form of light. The emitted light we also call as photon, the primary photon. This primary photon stimulate the further emission of photon from this particular area, that is stimulated emission. Before that, in order to get laser action, We just remember that there is a population inversion should be taken place. What is mean by population inversion? The population inversion nothing but the number of atom that is available in the higher energy state is greater than that of the lower energy state. That achieved by reflector, optical reflector. Here this particular part, the between this third and fourth, this junction where covered by that means glass act as a optical resonator that stimulate the emission of photon, and as a result of that further emission will be taken place. So here the population inversion taken place with the help of this forward bias. How the population inversion taken place? All the charge carrier available in the second layer and fourth layers are enter into third active layer, so that the third active layer have a large number of charge carrier comparing other part. That is a population inversion. So automatically after the completion of or after achieving population inversion, there is the emission of photon will be taken place. That is primary photon. That primary photon stimulates further emission of photon. As a result of that, large amount of photon come out from this particular junction that available between third layer and fourth layer. As a result of recombination, the outcome that is some light radiation will be come out from this junction and have wavelength 8014 Armstrong unit in the red region, so red color. So that light is monochromatic nature, coherent nature, does not diverge at all, extremely intense, so it is nothing but a laser. So advantage of that laser is intensity regarding it. Then some disadvantages are there. The cost of constructing the heterojunction laser, that is diode laser, is high comparing the homojunction laser also. Then application, as usually you know, this kind of laser we use. The laser produced from this semiconductor diode very useful for medical purpose and also in many other, particularly engineering field also, these lasers are very useful. So the question is, explain the principle, construction and working of laser. The working very simple. The second layer, positive hole, that enter into the third region, and fourth layer, negative electron that enter into active region, that is third region. Due to that third region where the accumulation of charge be taken place due to the injection of charge, that injection of charge from second layer and fourth layer to third layer with the help of this forward bias. As a result of that, a recombination will be taken place. As a result of recombination, laser light will be produced. So the very easy question. The same question we also discussed in the first semester also, that is in the engineering physics. So the conclusion of this one is, we get intense monochromatic light of wavelength 8014 Armstrong unit achieved by this way of the production, laser production. So that's, so this is the conclusion of this question. So seventh question, this one is actually, so far 7 video is over. Meet next video. Thank you.